Let's very quickly talk about if-else expressions in Scala. There isn't a whole lot of rocket science to if-else expressions in Scala. Really, the only noteworthy characteristic of if-else expressions is that they are expressions. They return values and in fact can be regarded as a combination of sub-expression blocks. First, a Boolean expression is evaluated. The return value of this Boolean expression must be true or false. If that return value is true, then the return value of the entire if-else expression is simply the return value of expression block number 1. If on the other hand the return value of the Boolean expression is false, then the return value of the if-else as a whole is going to be the return value of expression block number 2. Because the return values if-else expressions are actually similar to the ternary operator in C, C++ or Java. However, that leads to an interesting question. What if the else clause of an if-else expression is omitted, and then if the if condition evaluates to false, well, the return value is a special return value called nothing. Nothing is a Scala type that inherits from any. It can never be instantiated and is meant for use in situations exactly like this one, where an absence of a value needs to be signaled. In addition to nothing, Scala also has null, which is identical actually to Java's null. Let's check out if-else expressions in action with a really simple demo. The point of this demo is to drive home that if-else expressions have return values, which means that they can be on the right-hand side of assignments. Let's start by initializing two values called numer and denom with the values 22 and 7 respectively. Let me now go ahead and define the value pi using an if-else expression. I check that the denom is not equal to 0. Provided denominator is not equal to 0, pi is equal to the fraction numer divided by denom. If on the other hand the denominator is 0, then we return yet another special value. This one is called none. Notice how both the if and the else expression blocks are enclosed in curly braces, just as any other type of expression block would be. You can see Scala type inference at work. It has assigned the type any to our value pi, and that's because one leg of the if-else expression has a type double, but the other leg has the type none. The only common base class between double and none is any, and that's why Scala assigns the type any to the value pi. Let's try another experiment. Let's now set the value of the denominator to 0 and let's change our if-else expression so that it's now only an if expression. There is no else clause anymore. In this case, the condition, the Boolean expression will evaluate to false, and so the return value from this if-else expression is going to be nothing. Nothing is represented in the Scala REPL environment by a pair of empty parentheses, and that's exactly what you see on screen. This time, the type inference system assigns the type of any val, and that's because any val is a common base class for a double and for nothing. Scala has quite a number of types and values associated with nothingness. So let's talk for a minute about the difference between none and nothing. None is a value, it's not a type. Nothing, on the other hand, is a type. This is a type which cannot be instantiated. It inherits from any. Because it cannot be directly instantiated, there was no way that we could have returned nothing in the example where we had both if and else. Scala makes use of nothing in situations like the one that you see on screen now. And again, remember that in the Scala REPL, that's the interactive shell, nothing is indicated by a pair of empty parentheses.